class.
Good morning, Miss.
Okay, for today, our lesson will focus on the different conditions for triangle congruence. There will be certain thinking skills that we will emphasize in this lesson. One is visualizing relationships. Another is making and testing predictions. The third one is making convincing arguments. And lastly, generalizing based on some empirical findings. Through the activity that we will do today, you shall experience this full range of thinking skills. Okay, I'll show you something. Here it is. Tell me all your observations about these two. Patrick.
They're triangles.
Any other observations, Joanne?
They seem to have similar or the same size.
How do we know if that's really right? She claims that they seem to have the same size. What shall we do to verify that claim? Joanne?
We measure their sides and angles.
Okay. Yeah. Is that the only way by which we could check if her claim is right, Mark?
We will measure each side and look if the corresponding sides are equal.
Do you think there is a more efficient way of verifying if they have the same size? Andrea, how else may we check if her claim is right, that these two triangles have the same size?
Miss, we could try to just put one on top of the other. So they fit exactly.
They fit exactly, okay. So, a while ago, somebody said that they're both triangles. And then Joanne said they have the same size. We have verified that. So, when Andrea tried to put one on top of the other, they exactly coincided. Do you remember any term which you encountered when you were still in high school associated with planar figures that have exactly the same size and the same shape? Yes, Claudette?
If two figures have the same size and same shape, then they are congruent.
Okay, in this case, these figures are triangles, no? So, we have these two triangles that are congruent. You still remember, no? Those conditions that are necessary for us to say that two triangles are congruent? Joanna again?
For the case of the triangles, they should have the same measure of corresponding sides and same measure of corresponding angles.
She mentioned about correspondence, no? That's very important. So in this case, if these two triangles were labeled, remember these are the vertices, right? The sides, and of course you have the angles. No? The moment you're able to have a correspondence among the vertices such that corresponding sides have equal lengths, no? And corresponding angles have equal measures, then the two triangles are congruent. If we count, what would be the total number of conditions that need to be satisfied for two triangles to be congruent? Angela?
So 6 conditions must be satisfied,
Okay.
and because there are 6 pairs of corresponding sides and angles.
Okay, that's right. The question is, do we need to satisfy all those conditions for two triangles to be congruent? Suppose I have like this and this. Huh? Should I see to it that all of those 6 are satisfied before I can conclude that these two triangles are congruent? No. Okay, they say no. How shall we know how many would be the fewest? And what would be these conditions? Actually, we will have an activity that will tell us exactly the fewest number of pairs of corresponding parts that need to be congruent for us to be able to conclude that two triangles are congruent. But let's see how this activity can help us provide the reasons why what you think may be right. Okay, so we will now have an activity. I want you to work in pairs. Okay, so you have finished. Let's now discuss your results. Are you ready, Mark, to share with us your results? First, let us know your prediction before you actually constructed the triangles.
I predicted that given only one corresponding part of the triangle, we cannot conclude that the two triangles are congruent.
Okay, so were you right?
We are correct.
Well, you're correct. Could you please show us for evidence what you had done?
So, our original triangle was the right triangle, and the corresponding side is the one at the bottom, so of the two triangles. So, the corresponding side is equal to 7, and as we can see at the two triangles, even though the corresponding sides are equal, the two triangles are not congruent.
What unit did you use for the length of those centimeters?
So,
What about when you considered one pair of corresponding angles? What happened?
so the two triangles are both right triangles. So, one angle of the triangle is equal to 90 degrees. So, the corresponding angle are the ones that are equal to 90 degrees. So, as we can see, the two triangles are not equal because only one part of the triangle, only one corresponding angle is equal.
So what is your conclusion? Would having one pair of corresponding parts that are congruent be enough for us to conclude that two triangles are congruent? No. So is one the fewest number of pairs of corresponding parts? No. What would be the logical thing to do now if this is not the fewest? Yes, Marian.
The logical thing to do would be to check if two pairs would be the lowest number of.
We're doing this very systematically, no? Okay, so we don't miss anything. Okay, so what could those cases be? Berlin?
Could probably check if two sides are congruent, if that will be able to make the two triangles congruent. Or could actually also check for angles, if both angles or two angles are congruent, or a side and an angle.
Now, predict again, no? And then do the actual construction.
The overhead projector and show us your results.
So the original triangle we made is this big one. So as you can see, we've labeled the angles and the sides XYZ. And then we have copied the sides Z from this one and Y from this one. So, at first look, you would think they are congruent triangles, but if we superimpose them, they're not exactly the same. You see? This is the original vertex Z. So there. So,
Did the triangles that you construct look like the triangle that she had shown us? No, they look different.
Yes.
But did you have the same findings that she had?
Yes.
Okay, so can we conclude that if we have these conditions, that would be a guarantee that the two triangles will be congruent? No. Everybody got that?
Yes.
Okay, what about for this one? Just please go to the overhead projector and share with us your results, Claudette.
My prediction is that they're not going to be congruent.
And what turned out to
They are not congruent.
This one is our original triangle, and we call it first this triangle, and we labeled it angle A, and this is the angle A that we copy, and then we also copy the angle C here, and this is the angle C. So it turned out that the two triangles are not congruent.
Okay, shall we now have the last case for 2 parts? Marian, did you do side and angle? Okay, please show us your results.
So this is our original triangle, and then we constructed another triangle with the same angle, angle Z, and then we did the same side, which is side A. And as you can see, they're still not congruent to each other.
So again, what would our conclusion be? The triangles that you constructed were all different, no? But apparently you are getting the same conclusion. Okay, what's that conclusion? So Joanne, based on the results of our class, what conclusion can you formulate?
Okay, so based from the activity, the results of the activity, we can conclude that given two pairs of corresponding congruent angles, we cannot still construct two congruent triangles.
What about when you have one pair of corresponding sides that are congruent and another pair of corresponding angles that are congruent? This case, in short.
Given those parts, we cannot still construct two congruent triangles.
Okay, so in other words, when we only have two, we still could not be sure that the two triangles would be congruent. Could you please tell me the different cases that we need to consider for the 3 pairs of corresponding parts that are congruent? We now have 3. Okay, so what would they be?
We should have 3 sides, 3 corresponding sides.
Okay, so 3 sides. So we have like that.
3 corresponding angles,
So we have 3 corresponding angles,
and combination of sides and angles like
like
side, side, and angle.
side, side, angle. So let's denote that by these symbols.
We could also have side, angle, side.
Side, angle, side. And what's our symbol for that?
SAS.
SAS. Okay. My concern is, are these two just the same? Side, side, angle. I also have 2 sides here and 1 angle. Or are they different?
Yes, because
In what
with the
sense?
side, side angle, the angle that we are referring to is the excluded angle, while in the side angle side is the included angle between the two sides.
Okay. So, okay. Actually, we don't even need to refer to an excluded angle. No? We only need to say, this would be an included angle. Do you still remember your high school geometry? So you know what we mean by an angle that is included between 2 sides, right? So these two are different because this angle is included. Have we exhausted all the possible combinations of 3 pairs of corresponding parts?
Not yet.
What about part 3?
Angle, angle, side.
Angle, angle, side. Is to, how should we indicate that? Angle, angle, side. Like that.
And angle, side, angle.
Angle, side, angle. And I will write that as, how shall I write it?
ASA.
Yeah. So, both of these two, no, have 2 angles. So, are they the same?
No, because in angle, side, angle, the side is between 2 angles,
So, angle side.
while the other is outside.
Okay, so we shall call this the included side. So this is the side included between 2 angles. Is there anything else that we missed? Make your predictions again. Test them by actually doing the construction. You now have clean sheets of transparencies.
So we draw a triangle which has a 70 centimeter length and another triangle which has a 70 centimeter length. And if we coincide it together, magically it will be congruent.
If you would just try to remember, this is the very first time where we came up with a pair of triangles being congruent to each other. Prior to this one, we'd never got 2 pairs of triangles that are congruent given these conditions. Ryan, did you predict that in fact you will get those 2 triangles being congruent to each other?
Yes, Miss, we predicted that it will be the same with each other since they have the same sides.
So if that's the basis for your prediction, then may I also predict that the 2 triangles here will be congruent, since instead of having sides only, we have angles. Can I make that as a sound basis for a prediction?
Yes.
Okay, what did you actually get when you constructed? Anyone who could show us the results? For this one. Because Ryan claimed since all the sides which correspond to each other in those 2 triangles are congruent, then the 2 triangles must be congruent. Patrick, what do you say?
That assumption is wrong because having 3 angles doesn't actually mean having congruent angles too. Because when we did our drawing, when we constructed our triangle, it looks somehow bigger.
So do you have the triangles? Will you please show them to us?
So the original triangle is the one in the center, the small one, while the other triangle is the bigger one. So as you can see, they have corresponding congruent angles, but they are not congruent triangles.
What about the others? SSA, anybody? Who have done SSA?
This is our original triangle, and this one is the one that we have constructed by getting the first side. This one has the same length as this one, and this side has the same length as this side, and Okay, if we will superimpose the two triangles, we can see that they are not congruent, even though it has a side and another side and angle which has the same length and degrees. On the other hand, we also constructed this triangle wherein this side has same length as this one. This angle has the same degree as this angle. The other side, this side has the same length as this one. And when we superimpose the two, yes, we can see that the two triangles coincide perfectly to each other.
Okay, thank you, Mark. Like, I would guess that some of you may have had right angles instead of, did I see more or less like an isosceles triangle that he had shown? But nevertheless, did you come up with the same conclusion with regards to this case?
Yes.
Marie, are you ready?
Finish the angle.
Sige, go ahead. This one, angle side.
So this is the original triangle, and this one is the triangle we constructed using angle side. So we first got the angle B, it's this one, and angle A, and side B. As you can see, the two triangles are congruent using the angle side.
Were there other groups who did SSA besides the ones who presented? Were you the one who okay, so you had the same finding? In SSA, you had two congruent triangles? Or you did? So same conclusion as the others. The original is there, and the one that was constructed satisfying the AAS is the one on the right, no? Referring to the original, what you did was to measure angle B. Right, okay, so angle B is now this one. Angle A, so for the original, it is this one. For the AAS one, it is this one. How come this angle A on the constructed triangle was placed there and not here, or not there, or not there, or not there, or there? Why was it placed there? Because when she's superimposed like this, apparently these two line segments have the same lengths. Tama? The only given condition is that this angle is congruent to that. This angle should be congruent to another angle in this triangle. How come this angle was positioned right here?
We didn't really measure it. We just placed it there by coincidence.
By coincidence. If I can draw a line parallel to this here, then the angle that would be created would have the same measure as that angle. Why? Is it by coincidence that those conditions would give us two congruent triangles, AAS? Or will it always happen if you do this one more time or several more times or many more times, you will always get two triangles that are congruent?
So this is our original triangle. First, we have, for example, this is our given side, the 6.3, and the right angle and another angle from the top. And as we constructed our another triangle, we have this triangle. So this is the constructed line having 6.3 and the right angle and another angle. So as we put one triangle on the top of the other, we came up with two congruent triangles. We concluded that if you use angle in included side and another angle, two triangles can be congruent.
Can we now determine the fewest number of pairs of corresponding parts that have to be congruent? Two triangles to be congruent? What would that be, Angela?
We need at least 3 pairs of corresponding parts that are congruent to make sure that we will be able to construct 2 congruent triangles.
Okay, very good. So does that mean then that this would also give us congruent triangles? The moment we have 3, automatically we can have 2 triangles that are congruent. Angela again.
Not necessarily, but as we have already proved that once we use the SSS, the SAS, as well as the ASA theorems, then we can be sure to make 2 congruent triangles. But if we use AAA and SSA, those 2 theorems will not be sure to come up with 2 congruent triangles.
Okay. Okay. Did you say something about AAS?
Oh, okay. Miss, can I explain
Yeah,
why
sure.
AAS is a theorem that can be used for triangle congruence, because we have already proved ASA. So for example, we have a triangle like this. And then we already have, so it's AAS, right? So I label A. These are the pairs of corresponding angles. And then this side. So we are not sure if this angle would be the same as on our other triangle. But since we know that all triangles have a sum of, all the angles in the triangles have a sum of 180 degrees, we can be sure. So for example, this angle 1, this angle 2. We can be sure that angle 3, its measure will be 180 minus angle 1 minus angle 2. So we can be sure that angle 3 will be the same as on our other triangle. So we now know that angle 2 side and angle 3 are the same. And if you can look at it, it's also the same as ASA. So AAS is by ASA also sure to make 2 congruent triangles.
Oh, well said. I didn't have to explain anything anymore. Thank you, Angela. In other words, what she's saying is AAS is a consequence of ASA. By the very relationship that she cited, the moment you have 2 pairs of corresponding angles congruent in 2 triangles, whether you like it or not, the third pair would have to be congruent to each other. Okay, so that was good, Angela. So now, it's not only by coincidence then that Marie's group got these 2 triangles. And Angela also mentioned the word theorem. No? In geometry, when we say theorem, we have certain mathematical assertions that need to be proven before they are accepted as true. In the activity that we had, we were able to show that these conditions, SSS, SAS, ASA, were able to give us 2 triangles that are congruent, right? We didn't prove that. And there was no group here which was able to give any counter example. All of you were able to get 2 congruent triangles for all the conditions. This. But is that a guarantee that it will never happen? No? That if some other constructions are done following these conditions, the 2 triangles will not be congruent? Can we be confident that they will always be congruent? We have not proved them. Here, surely, if this is true, if we take this as true, then necessarily this has to be true, no? So this one was proved on the basis of the ASA. What about for the others? We've not proven them. It just so happened that all of us had the same results and conclusions. How sure are we 100 years from now? Okay, that will this still be true? Okay, actually, For this lesson, we shall take this as congruence postulates. We accepted them as true without having to prove them. But if you go to other systems of geometry where they use other approaches, say for transformation or motion geometry, in fact, all of these things, or all of these conditions that we accept as true could be proven as true. So we can be confident that we are correct. Although we are accepting this as true statements without any proof, through the activity we have shown that there are underlying bases for these things that we do accept. Like for instance, prior to this lesson, did you ever ask yourself why you could not have 1 as the fewest, 2 as the fewest? Why 3? How come even if we have SSS, AAA will not give us the same result? Right? How come we can have AAS but not SSA? So through your experiences constructing those different triangles, you saw that you were able to come up with examples, no? In fact, counter examples that show that these, where else, and these do not give congruent triangles. So in mathematics, before we believe that something is true, we need to be convinced. We need to be provided with some convincing arguments or evidences. So let's wrap up our lesson. What is it that we learned?
So what we learned today is that 3 is the number of pairs, is the least number of pairs of corresponding parts that have to be congruent for 2 triangles to be congruent. So these are sides SSS, side angle side SAS, angle side AAS, and angle side angle ASA.
I think at the beginning I already mentioned this. First, you were made to visualize. On the basis of your visualization, you were asked to make predictions. So even before you made your actual constructions, you would be imagining how the 2 triangles would look like when there are a certain number of parts that are made congruent to each other. Third, you verified if your predictions were correct by your actual constructions. And then, on the basis of the findings, you made conclusions and generalizations. The generalizations resulted to this, and Mayan had already told us about them. So thank you for participating in today's lesson. Good morning once again.